Hey there, how's everyone doing? Hope you're doing great. I am. I'm having an awesome day. And this video, it's going to be a short one. We're going to talk about the size and the isEmpty functions of linked lists. Here's the code. This is why I say it's short, because they're basically self-explanatory, right? So to figure out if a list is empty, what do? All I have to do is check its head. If the head is equal to none, then the list is empty. And if the head is not equal to none, then the list is not empty. So that's what this function is. The size is a little bit different. However, it's still not complex. You just traverse the entire list and count each node you visit. So we first set a variable called count to 0. Then we set our current node equal to the head. Then we loop. And when do we loop? Well, we loop as long as our current node, as long as we have a node we're actually pointing to. It's not pointing to none. And as long as that's true, we increment our count. And then we just basically set our current node to get the next node, just like we have been doing many times. And then finally, you return the count. So that's all that the isEmpty and size is. The size function here will be a lot easier if you have a property, or excuse me, a size property. Basically, every time you add a node, you're tracking it at the linked list class level, and every time you remove a node, you're also, subtracting one from that count at the class level. Then you don't have to sit here and traverse the entire list. You just reference one class property, very similar to what we're doing up here. I'm going to add a tail pointer and a length property probably in my last couple of videos for this. So right now I don't have that length property, so I have to traverse the entire list to get the size of it. Let's see, isEmpty is O to the 1. All I have to do is check one property. And if the head of the list is none, we know the list is empty, you return true. If the head is not none, it should point to some type of node object. Then we know it's not empty, we return false. Size in this case, in my implementation, is down here into the O to the N, right here, because I do not have a length property. If you do have a length property, it's O to the 1, because you just, very similar to checking the head, you just check the length of that length property. And again, I will do this probably in one of my last videos here for this series. Other than that, here's the code. I'm not really going to type it all out, because I mean it's pretty self-explanatory, but I will show you that I got some test cases here. So here's where I'm testing the isEmpty function. We're first creating a new object, then we are making sure that the head is equal to none, and then there it is, isEmpty should be true. Then I'm going to add a node, and isEmpty should be false. Then I'll remove that node, and isEmpty should be true. So that's the isEmpty. And then the size is basically same kind of style of tests. I create an object, make sure it's empty, and make sure the head is none. Then I just sit there and I check that my size returns 0, because it's an empty list here, so make sure I don't get any errors there. Then I add some random nodes, and I'm checking the size of my list based on how many nodes I add or remove. And that's all those test cases are. I can run the tests. And there you go, they all pass. So that's it. Here is the code in the singly linked list class right there. All this code's on GitHub, but here's my isEmpty and my size function, just like you just saw in the video. So short video, because pretty simple methods here to implement.